In this tutorial, we are going to see about the implementation of collision inside the Unity game engine with standard collision type objects such as box colliders, as well as custom mesh colliders and convex mesh colliders. So let's take a look at collision inside of the Unity game engine. We had already added a box collider to our floor piece here. There are a number of different types of collisions in Unity. So I'm just going to select this trim piece and let's look for collision or collider, if I can spell. There we go. We have box colliders, capsule colliders, circle collider, or these are 2D, mesh colliders, terrain colliders, sphere colliders. Those are the ones that we're going to use the most. So just take a look here. A box collider is simply that, it is a box. So it's going to apply it to this model. If the player collides with anything here, even though this is empty space, then it will thwart the player from going through here. But things can collide with it, whether it's players, enemies, bullets, all kinds of different things. The collider is here to interact. We can adjust it by changing, say, what the pivot position is of it or what the size of this is. There is this nice little edit collider tool that if we click on it, these little dots pop up and we can grab and move each one individually. Ooh, come on. There we go. Oh, I have snaps turned on. Let me turn off grid snaps. There we go. So we can grab and we can move each one of these components to see, okay, how can I better make this fit? Now, obviously, it fit pretty good here to begin with, but sometimes you do need to make small adjustments. To remove a component, we can right-click on, go to Remove Component. Let's go to Capsule Collider. Capsule Collider. It has a radius to it, so it's more like a sphere in a way, but then it also has a height. So that's what our little pill player character uses. Capsule colliders is very often what players are used for, but they have the same sort of componentry to them as the box collider, where we can grab these little dots and we can make quick adjustments to our collision. You can also adjust the direction that this capsule operates on. So if we use the X or the Z, you can add multiple colliders to an object. Sometimes that ends up being beneficial. Sometimes it ends up being a little overkill. So if I used a box collider and a capsule collider, I can do that for whatever reason. But sometimes you do end up with complicated pieces of geometry that could use those colliders. Let's look then at the sphere collider. Sphere collider is just what you would think, because it has a radius. It's very similar to a capsule collider. It just cannot be stretched in a particular direction. And it operates the same way, where we have these little points that we can move to scale and reposition our collision. Now, the box collider, the sphere collider, and the capsule collider are all Unity-based colliders, and they are really efficient because they are engine-based colliders. There is one more collider type that we would use for most things, and that's the mesh collider. The mesh collider uses the physical geometry for a collision. It ends up being the most accurate to the form. However, it can be problematic when it comes to physics, just because it's more complicated. So sometimes you may have bullets that pass through it, or characters that if you ever seen a game where you try to push against a wall super hard and eventually you can push your way through it, that's because odds are they're using a mesh collider, and so you're breaking the physics. So you have to be careful with mesh colliders. Something that can make them a little bit better is if they are convex meshes. And checking this box, then Unity is going to try and rebuild a simpler form of the geometry for much better collision detection. This works pretty well. It might, not be exactly form-fitting with this little bit right here, but I think that that's going to work out just fine. So for this, I'm going to use a mesh collider, and I'm going to hit apply all. That way, any prefabs that I use after this of this particular model, this model in here, this trim, is going to have that mesh collider attached to it. So this floor piece over here, I am going to add a box collider to it. There we are. And again, this fits pretty well. Let's apply that. I'm going to add the same thing here, box collider to my crate, and we're going to apply the changes to it. For this canister, we can do something a little bit more robust. Let's do a mesh collider that is convex, and we'll get something a little bit closer to its form built out. And we're going to override, apply. The wall, we are just going to use box, apply. This pillar can use a box, apply. This little walkway right here, there's not a ton that's going to be real noticeable, so we'll just use a box collider for it as well. And we'll apply that change. I forget if I did for this one. Yep, I did. For the spaceship, let's do a mesh collider, and we'll tell it to be convex. So pretty close. It's going to get a little quirky up through here, but overall, it's going to work just fine. So apply. The stairs are going to potentially be a little bit trickier. So let's do for this part right here, for the catwalk base, we'll do a mesh collider that is convex. So we'll apply that. For the railing, if we wanted to ensure that we could like shoot through this, then we would not want to do a mesh collider that was convex, because it will block that off. So in that case, we would probably want to use just a regular mesh collider. If we are concerned as far as like the physics to this, we could add multiple box colliders to it. So if we did like a box collider like that, and then added another box collider. And we did kind of like each one of the railings here. We might get something that was a little bit more accurate, and that would probably work okay. It probably, even though we're using 3 colliders to make this happen, it's probably still more efficient than utilizing a mesh collider as far as physics response. So it'd probably be okay to do something like that. So we'll just say we'll do that for this railing. Overrides, we'll apply that. This is the one that things end up getting to be a little bit tricky, because if we do, let's do a mesh collider. And if we were trying to walk up these steps, it's going to be hard because our character is going to bump into every single one. But if we were to simplify it by going with convex, it's going to go through here and it's going to close all this off. So there are ways that we can import and use custom meshes as collision inside of Unity. So let's look at how we can do that. So back over here in Maya, I am just going to take and isolate out my stairs, and I'm just going to build a really simple mesh in here for my stairs. It does not need to be unwrapped. It is not a super complicated model. It is to make the collision detection more efficient, and also it ensures that if the player is trying to interact with this, they're not going to run into issues. So there we go. There, that would make it easy, a real nice slope so that the player can walk up it. And then if I want to use something simple for the rest of the stairs, I'm going to duplicate out a copy of these steps just so I have one as a safety. And then I am going to grab the railings. And I'm just going to separate them so that I can delete out the stairs. But then all this stuff right here, I can combine that. I'm just going to add a standard material to it. And there we go. I could use that as my collision. If I wanted to simplify this even more, I could even get rid of a number of these edge loops just to simplify how many edges are being considered in the detection process. Control backspace, that will remove those edges. So double click, hold shift, double click. There we go. Control backspace, there we are. And that will simplify that geometry. So if I export this, I'll just call this stairs collision. And I'm going to snap my pivot point. The location of this object and its pivot point are incredibly important because it's going to be added to the model relative to its own scale and pivot point. So before you export this, make sure that these two things share the exact same location and space. So again, just to emphasize that this is where the model, the game model was exported from. This is where the collision resides. So they both reside here at 0, 0. So let's take this game exporter. I'm just going to export selection. I'm going to throw this just on my desktop, and this will be stairs collision, and we'll export it. So back over in Unity then, let's go back underneath our props catwalk, and I am going to grab a hold of that stairs collision object, drag and drop it in. And now if I go to the stairs here, and I'm going to do mesh collider. And for the mesh collider in here, there is a mesh that it references for using the collision. So if we open this up, so this is our stairs collider object. If we click the little button to open it, we'll use it. But I did not change the sizing of this when it was imported. So the original set of stairs is 0.1 and uncheck convert units. So we want to do the same thing for this. So 0.1, uncheck convert units, apply. And now if I go to this and add in that collider, we can see it pops up in here. And you can see that the much simplified geometry being added to our model. So now if the player were going to walk up that, it would be a nice smooth slope to walk to the top of that catwalk. So from there, we'll do overrides, apply all, and then we should have the collision set up for all the objects in our scene, and we have applied them to our prefabs. So we can go from here and we can start actually populating our scene with these models.